Hello guys, welcome back to our YouTube channel. Today's video is about the chapter Work Energy Power from class 11 and we're going to discuss some concepts from those. So the first concept in that is collision, which is a slightly confusing concept that's not given in as much detail in NCERT. So let's move first to the case of one-dimensional collisions. As far as one-dimensional collisions are considered, the concept is explained well in NCERT. But the formula that NCERT has given is considering only when the first body is moving and the second body is at rest. That is a case like this, where a moving body of some mass comes and collides the stationary body. So only this part of the formula has been included in NCERT. But in NEET there can be some questions where the second body also is moving either in opposite direction or in the same direction itself, and in such cases, to find the final velocity of the first or the second body, we need to apply this formula. That is, V1 is m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2, and V2 is 2m1 u1 by m1 plus m2 plus m2 minus m1 divided by m1 plus m2 into u2. So these both formulas are got from the conservation of momentum, which I have written as COM, and the conservation of kinetic energy. So those two things give us two separate equations, and on solving them we can arrive at these two formulas. And these two formulas hold true only for a perfectly elastic collision. And to solve perfectly inelastic collisions, we have to just use conservation of momentum and the fact that both the bodies stick to each other after collision. So next let's move to the concept of two-dimensional collisions. So as you can see here, a moving ball with initial velocity u collides the stationary ball, and this is the point of contact, and after that the two balls fly at an angle of 90 degrees to one another, as in the case of perfectly elastic collision. So to solve such problems, you need to use three things. One is the conservation of momentum in two directions. So as you can see in this case, we need to apply conservation of momentum along y-axis, and we get a relation between v1, v2, m1 and m2, and we need to apply conservation of momentum in the x direction, considering the momentum of this initially and the final momentum of both of these components in the x direction. And next we need to use the conservation of kinetic energy itself, and since kinetic energy is not a vector, it's a scalar, so there can be just one equation which is half m1 u square is equal to half m1 v1 square plus half m2 v2 square. Then next we use the 90 degree final angle fact. That means that both these balls should be inclined at an angle of 90 degrees. Their path should be inclined at an angle of 90 degrees after the collision. So this is a very important fact to be used in questions, especially in the case of elastic collisions. But in inelastic collisions this doesn't apply, and usually two-dimensional inelastic collisions are not a common question in NEET. So next let's move to the concept of coefficient of restitution. So now let's discuss the concept of coefficient of restitution. This concept is not mentioned in NCERT, but there are a few NEET previous year questions asked on this concept. So coefficient of restitution is represented by the alphabet E, and it is the relative velocity of separation divided by the relative velocity of approach. That is v2 minus v1 by u1 minus u2. Now this change in sign, like v2 minus v1, it should have been u2 minus u1, right? So this change in sign I will explain when I am taking this example over here. So all you need to remember is that the coefficient of restitution is relative velocity of separation by relative velocity of approach. So as you can see over here, if two balls are coming towards each other with velocities u1 and u2, at this point of contact, if both the bodies are smooth, then the collision becomes perfectly elastic and the coefficient of restitution is equal to 1. Now how this is equal to 1 is left up to you. I gave you the formulas of V2 and V1 in the last part, and you can simplify that and you notice that for perfectly elastic collision E is equal to 1. But if it's a perfectly inelastic collision where bodies stick to one another, the relative velocity of separation is obviously 0 because both their final velocities are same. So V2 minus V1 is 0. So the coefficient of restitution becomes equal to 0. Now let's take an example where a ball is hitting the ground, and this ground surface has a particular coefficient of restitution with the ball at the point of contact. So suppose there is a ball that is released from a height h1, and just before it's going to touch the ground, it has a velocity u2, suppose. Now this u2 would be equal to root of 2g h1, which is a very standard formula, and after its contact with the ground, depending on the coefficient of restitution, it will get a velocity, right? And that is the velocity v2, and because of this velocity it will go up to a height h2, and the same formula applies, that v2 is equal to root of 2g h2. So since coefficient of restitution is equal to v2 minus v1, and over here, since the first body is the ground, second body is the ball, the ground never really moves, so v1 is also 0 and u1 is also 0, so it becomes v2 minus 0 by 0 minus u2. But if you notice that the direction of the velocity vector of u2 is opposite to v2, so v2 by minus u2 can be thought of as v2 by u2 itself, because v2 and minus u2 vector are in the same direction. So E is equal to v2 by u2, and just as discussed, the formulas are root of 2g h2 by root of 2g h1. So simplifying this, you would get E is root of h2 by h1, and if you square both the sides, you get h2 is equal to E square into h1. So from this we can derive a general formula that hn is equal to E power n h1. So you can imagine this, right? You are holding a ball and you drop it from a height, and it just keeps on bouncing. It never rises to the actual height, and each time it bounces, the height reduces. That's because the floor and the ball have a certain coefficient of restitution which is less than 1, means the collision is not perfectly elastic, neither is it perfectly inelastic. It's somewhere in between, and hence the ball continues to bounce, but after some time it dams out. So this is the concept of the coefficient of restitution. Just like how I found the formulas for general height relating to original height, there are formulas for time also, and such formulas can be easily derived if you know the concept. So next, let's move to the last concept, that is part of a chain hanging from the table, and how to solve such questions. Moving on to the last concept of this video, which is actually a type of numerical, that is the hanging chain. So this is a very common question where there is a table which is ending and there is a chain hanging off the end of the table. There is a part x of it which is usually given like 1/3 of the length or something like that is hanging, and to find the work required to pull this entire chain back out of the table, like the entire chain should be on the table. So in such cases, we use this simple relation that the work done is equal to change in potential energy. So now, to raise this chain onto the table, we have to increase the potential energy of this part of the chain. So to do that, we need to have a change in potential energy of m into g into x by 2, where m, that is the mass of the hanging part of the chain, is got by the unitary method, that is, if you take mass density of the chain as m divided by L, because it's of mass m and length L, and then multiply it by the length of the part itself. So it's mx by L is the mass of the chain, g is acceleration due to gravity, and this is a very crucial point where we take the h is equal to x by 2. So this is where most students go wrong, and even I went wrong initially when I solved some questions. That's because we have to consider that the center of mass of this entire part of the chain, that is this much part, has been moving up. We have to not consider that the entire chain, like the bottom end also is moving up. We have to consider that it's only the center of mass of the chain that has to be raised from here to here, and we can replace the entire part of the chain by a single mass that is placed itself at the center of mass. So the height required to raise wouldn't be x, rather it would be x by 2, this height. So the formula for work done would be mgx by 2, where m is mx by L. So substituting that, we get work done is equal to mgx square by 2x. So taking an example would make this easier. Suppose x is equal to L by 3, that is, they have mentioned the question that 1/3 part of the chain is hanging. Then substituting L by 3 for x in this equation, we get mg into L square by 9 divided by 2L, which is mgl by 18. So the work done to lift 1/3 of the chain onto the table would be mgl by 18, and if we hadn't used this x by 2 over here, the answer would be drastically different, and it would be mgl by 9 itself. And usually such options are there, so you can get confused in such cases, but you need to remember that it's not the like you have to treat the entire chain as a mass placed at its center of mass, and then you have to solve this question. So thank you so much for watching this video. Hope it helped. Please do like and share the video and subscribe to our channel.